skip the very first slide, okay, the recap about linked data that we just learned, the motivation, modeling, some description, and so on. But then I focused here on the RDF part. Okay. A little bit about RDF. Okay, we all know already that it stands for Resource Description Framework, in which it is framework for describing resources on the web. But of course, nowadays you can use it for everything. Either it is available on the web or not on the web. And it has a syntax in XML, but nowadays I think more of the popular syntax will be JSON, Turtle, and many more. XML is too lengthy, verbose. And the very important thing is that it's part of World Wide Web Consortium, W3C standards and recommendations. So it's kind of open standard driven by the World Web Consortium. And okay, the concept we already discussed. There are two ways of representing RDF statement as a graph, notation, subject, predicate, object, subject, predicate, literal. And the predicate is designated by directed arrow. So it is directed, okay? Every time be reminded that you need to make it an arrow because it has a subject who is the role having certain relationship with another object. And it can be on the backward direction, and it can be multiple predicate as well. This subject may have a relation with this object on this predicate one, and maybe the same different relationship, but having the relationship with the same object using different predicates. That is also possible. Okay, RDF can be drawn as a graphical model. Okay, but the serialization of RDF must be in the serial form, right? Text encoding, in which we will learn the text encoding. Okay, in terms of data types available for the literals, the recommended data types that you can use would follow XML schema data types. So you may need to refer more on some of the XML knowledge. That is, you can use XML schema data type, XSD, as a prefix for string, integer, float, and many more, date, time, Boolean. And this data type is for this. When you want to describe your resource as literal, you may want to define proper data types of those literal, okay? And that is what you can use, any of the available XSD schema data types. And we already see examples, right, about Bangkok and so on, in which we draw everything using URL, and it's very long and lengthy, but that's fine. Okay, let's look at this example. We have a resource here. What happened? Okay, this resource with this URI, blah, 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 Rishi Jain. I don't know what is this, but this resource says that I just call for short, okay, Rishi Jain knows Sahaporn, okay, and this Rishi Jain has a predicate name, false name, Rishi Jain. You can infer, guess that, okay, this may be a person, okay, but actually it does not say yet whether this is a person or some other types of resource. And this knows, okay, this is just to introduce a little bit. There are kind of standard vocabulary, several of the existing standard vocabulary for describing kind of common stuff, such as people, person, place, and so on, right? There are those vocabulary you can reuse and follow. This one, FOF, stand for friend of a friend. It's kind of widely used vocabulary, standardized one somehow, but not standardized by some professional organization or something, but it has been widely accepted, kind of de facto, to describe people, their workplace, their professional occupation, and so on. So many of the example you would see will be based on FOF if it is related to people. So as I said, sometimes some predicates, you don't know the meaning, and it could be ambiguous, and we may need to differentiate or make it a very unique meaning, unique identifier. For example, the word knows, right? If we don't put it as use a URI mechanism, but knows alone can mean many things, right? I know some knowledge. I know you, I know the place, I know what, but knows in this context defined by FOF means a person knows another person. It has the very specific meaning. So this way, when I refer to this URI for knows, it just that knows. Person knows a person only, something like that. Okay, I can define formally and properly what does it mean by this predicate. Okay, and if you want to use the predicate that I define here with this URI, you need to follow the definition that I define for this. The same for a name. This one can only be a name of a person or an agent, an entity. It cannot be a name of, let's say, an animal or a name of a place or something like that. If I put the very specific definition of the predicate, then it's known that it must follow this meaning. And this helps with some kind of inference. That means inferring new knowledge. What does it mean? For example, as I said, I don't know what Rishi Jain, what this thing or resource refers to. How can I be sure that it must refer to a person? Can Rishi Jain refer to something? Suppose, okay, suppose, but we know by the types of name or something, but suppose for the computer machine, how can the machine know that this must be a person resource? Not by the name for sure, but by this knows or by this predicate name in which I already mentioned that. If my schema, we will learn next time that how can we define RDF schema? Schema is kind of you create a vocabulary that you may put some constraint and restriction and also definition, right? If I define in my schema that you can use this predicate knows in a way that a person knows another person, it means that this must be a person. Otherwise, you cannot use these predicates. And this also must be a person for sure. Otherwise, you cannot use this predicate. So even we never say that Rishi Jain and Sahapon are person. We know by inferring that the domain of this predicate must be a person. The range of this predicate also must be a person. Then by sure these two resources, if they follow the restriction of using the predicate, they must be a person, both of them. Okay. So even no one tells, we know by this kind of, and as I said, by following this formal knowledge representation mechanism. All right, then that's about the example of a given statement and graph. Then when you want to exchange or send information or share or publish information, you are not publishing all this as a graphical form or exchange this information to other programs in this way, right? You need to, we call it serialize. You need to serialize it in a text character. And XML is the very beginning initial syntax, standard syntax. You may need to find some extra time to read how this syntax should be followed. But I give some quick explanation here. This is the kind of declaration saying that this whole document is XML document. Second, this is the start element, the root element, and this is a open and close element. Okay, open and close here. So we start the open element RDF with RDF element. Okay, inside this okay, please find some time. Okay, we have Friday, Saturday, and Sunday, Monday, and we see each other on Tuesday. So there would be some of the reading stuff and learning stuff that I would like you to do some self-learning on RDF syntax and XML syntax. This is called prefix. This part is called namespace. And this is what I said. It's a way that allows us to do some kind of syntactic shorthand. We want to say that this namespace, okay, will be kind of abbreviated by using this prefix RDF. Similarly, another namespace, http xmlns.com forth 0.1. This long namespace will be abbreviated by forth. Oh, sorry. This long namespace, what does it mean? Actually, every time when you refer to some URI, right? Usually, we would define certain mechanism that the very preceding part should be standardized somehow, and then you change after the slash, after the hash or something. You may use slash mechanism or hash mechanism. But let's follow, let's look at this fourth one as an example. Every predicate in this defined by fourth, everything defined by fourth vocabulary. Okay, we call vocabulary or schema is the same thing. Okay, so everything will be after this slash that will change. So what we could do is that, I mean, every URI will be differentiated in the fourth vocabulary after this slash, more or less. Okay, so we can say that every time you just put this long namespace to be abbreviated by fourth, and then every time you say fourth colon name, it would mean fourth followed by that name, or fourth colon no, it means, so this is a prefix. So this will be when it is, how to say, when it is processed, okay, this would become as the long URI name. Like this, okay. And the same for name, when you use both name like this. And the same for RDF. So RDF description here, RDF about here, actually, it means that you need to concatenate this for this abbreviation. You replace the abbreviation by the long namespace. Okay, and that's the mechanism of doing this. And that could make the syntax when you draw a graph, when you write some statement, shorter and readable by human. Okay, anyway, so this say that this XML declaration, then we start this RDF and end this. Inside this root element, you define all the namespace and prefix that you want. Then under this, you can start using all the namespace and the abbreviated name, the short name. So to describe, it is RDF colon description, and you are about to describe some resource. You say RDF about what resource you're describing. Then after this, you can start having any predicate you want to describe, such as name and knows. If it is a literal, you can see that it is fourth name, Rishi Jane, and then finish the fourth name element, close it. If it is an object, you say that Rishi Jane, right, knows this URI. So you use RDF resource. But if it is a person name, a literal, you just define different syntax, different way. Okay, these are just two different way. But with RDF XML syntax, there are multiple, several ways to do as well. Okay, what else I will, this is another example. And okay, what is it that you should practice is go to this URL to get World Wide Web Consortium RDF validator tool and try. You can try writing any of your RDF XML syntax and make it parse and make it shown as RDF graph. So let's look at this. Okay, the default one. This is the default one. I show the triples and the graph. Okay, pause. Here, the text just say RDF, right? With the namespace and the prefix. Having DC for Dublin core. DC is a standard vocabulary. Dublin core is standard vocabulary for describing mostly library resources, book, materials, CD, audio, people writing, authoring books, creative work. Okay. So this is the standard URL for Dublin core. And if you follow some existing vocabulary, it is our job, right, to find out what is the URI namespace for those vocabularies we want to reuse for describing. We are not to invent any new vocabulary every time we want to describe something, but we should reuse existing standards, such as if we want to describe about people, both already exist. If you want to describe about library resources, Dublin core already exists. If you want to describe about things similar to DBpedia place, then maybe you can reuse DBpedia ontology that already exists as well. Okay, anyway, here is the original RDF XML document in this example. It's a description of this web page, website, World Web 3C, and has the title World Web Consortium. So this one render as a graph. It has this resource, subject, predicate, object, in which everything is presented in full URI form. This resource has this predicate URI with this literal value. Okay, World Web Consortium, title, World Web Consortium, and so on. You should try writing your own. I can try copy and paste my example. Where is it? Okay. Do I make it? Okay, should be. Okay. And oh, I forgot to explain. In this, you see 3 different ways of the same RDF statements. First, as triple, subject, predicate, object. Second, as RDF XML syntax. And third, as a graphical model. Okay, these are 3 different ways of representing the same statement. And you can try writing more, right? Uh-oh, let me see. I think something is not correct here. It doesn't show. Okay, let me find out what is wrong. There must be 2 statements. Okay. One is missing. Okay, this actually has 2 statements. Rishi Jane has the name Rishi Jane, right? And then has predicate knows another object, another resource, and that's it. Okay, okay, this is missing. Okay, I correct this later. So what you should do as a practice, okay, is, and we continue next time, but please read this entire slide because they are not too difficult to read and understand by yourself. But I do have some exercise that I request you to do as homework, and next time we look at them. Something very simple and basic. I already have some statements. You just try to convert them into RDF syntax format. Draw the graph, identify subject, predicate, object. Every time try to use URI standard form, okay? Not just say TG something, but make it a standard URI form. If you can search what is really available in Thai Airways, for example, do it. But otherwise, make up some example URI, mock it up. Okay, that's fine too. Predicate must also be URI. If you can find some standard vocabulary that can be used to represent airline and flight, that'd be great too. And something else, another statement about airlines, and draw them. Maybe another thing about shopping item, draw them, okay, and even explain a little bit more. Some of the exercise, I give it to your freedom. You can try to describe variety of the things about the size, the car, the horsepower, the engine, the color, or whatever, right? I think up to your imagination that what you should describe them. And next time we will see and share this. So try to make it in the graphical form. I mean, in digital form that you can share the screen and so on. And will be good if you can try to write them in RDF XML and make it passable on the validator tool. So you can practice the syntax in RDF XML too. Okay. Later part of this will be kind of other serialization formats available. I would focus that you must know RDF XML. This is a must know. Turtle is kind of very handy, I would suggest. Triple entry JSON and triple entry Turtle, they are kind of similar. If you understand one, you will be able to understand the others easily too. JSON, I think it's very familiar with you as well, as you're already in the world of coding and using JSON, right? So try to see how RDF and JSON would be represented in JSON format. Okay, I think that's all for today. So next meeting, next session, okay, please complete the exercise and then we will discuss and share, and I will see if there are some interesting thing I could point out as on your on the homework. I will update also the assignment number 1, not the reading. Reading I already upload everything, right? It's you to choose. Assignment number 1 about modeling. It will be about modeling RDF statements, describing certain things, but I will define some details and share with you. All right, so that's about today. I'm sorry, it's 10 minutes after 12, but any questions, anything from your side? I saw the RDF model that I want you to share, right? So may I request those who are online, because you already connect, that's for sure. Those who are in class, you need to try connecting very soon. I cannot scroll here. Okay. The online one, I need your sharing on the very first exercise. Okay, let me move to that part. Okay, the very first few slides, who can volunteer doing this? I need a few sharing. I have Ramesh, Paramik, Alvin. Am I correct? Okay, I do random, alphabetically. Alvin, do you have anything that we can discuss and share?
I think the subject is flight.
No, sorry. I don't want you to explain. You told me the result.
Oh, the end result.
The drawing, you need to write down when you work on something, right?
Oh,
yes.
Yes.
Possible, you write down, you type in, you have your answer ready. Do you have that? If not, I skip.
I don't have it ready, ma'am, but I'm writing it.
Okay, Ramesh, can you share some?
Yes, Professor. Can you provide me access to share?
Nothing? I don't have it.
I'm unable to share, Professor.
Slowly, please. Sorry.
I am unable to share my screen if it's possible. So, can you allow me?
If you want to share the screen, I will stop sharing because we two people cannot share the same screen. Cannot share the screen.
Yes, I have prepared some.
Okay, I can stop and we can share, right? Anything?
So I have,
Okay, perfect.
yes.
I can see the sharing now.
So the subject in this case would be the flight TG 676, and which is operated by would be the predicate, and the final Thai Airways International would be the object in this case.
Okay. So this is the first one. Thank you, Ramesh. I have some suggestions from friends as well. This graph, does it look the same as yours? Do you have the same? No, same. Anyone have same? Okay, anyone have different? Sirikit, you have something different? Subject and object you made as URI. Okay, good. But can you share the screen, Sirikit? Is it on paper? Okay. Others, anyone has modeled the graph in a way as a URI? Risha? Yes, but it's on your screen. Okay. That's very good, Rich. Okay, then let's Risha sharing. I will comment and then thank you, Ramesh. We may come back to you
Sure.
for other parts as well. But Risha, please. You may need to. Okay, no problem. We can wait. Relax. That's no hurry. Okay, others, there's still a few more statements and model. Okay, if you can make them ready somehow, okay, we may call for your sharing and then we discuss. There are quite a number. Okay. Okay, please make it big. You can sit at your place. Yes, thank you.
This is what I made for the first statement. For flight TG676 operates by Thai Airways International. In my subject, I made it in the form of a URI. So the flight information is the main website, and information about the flight TG676 will be under the page flight information. That's what I thought. And then in predicate, I could not find the like the general term to describe what I'll put this under. So I put flight operations, and then again about the flight, like referring to the Rishi Jain example, I did it like this. So this is the first one, and this is the second statement. The only difference I made was in the this part of the URI, and for this the subject was the same in all the three statements. And this is the statement 3. And for the properties of a handbag.
Okay, stop here, please. First, thank you, Risha. I think we do have another slide here. If actually you can combine everything. Here. This one, actually the meaning of this exercise, the last one is to kind of combining or aggregating all the graph, all the three statements. So I believe that you can do that easily, right? Actually, you can merge or kind of combine the three graphs together, and then you will see that we can have, okay, maybe later on, if someone has a result on this combination of three statements, anyone has made? Faye, you want to share? Yes. So thank you, Risha. That's very good. Actually, the very first version from Ramesh, that is each statement is kind of not in the form of URI, but actually it could capture the meaning somehow. But basically, that's still for human in terms of the graph, the model that machine can process and do some reasoning and some work further on must be in the form of URI. So this is from Faye, right? Okay. Yes, this is the one you put into. Can you explain this?
So for these, for exercise number 3, I think there are three predicates: operator, flies from, and flies to, with 3 objects: the Thai International Airways, Bangkok, and Tokyo. So I tried to also find the URIs through DBpedia, and this is the graph. So the flight TG676 is operated by Thai Airways International, flies from Bangkok and flies to Tokyo.
Okay, interesting. I have a few points. Okay. If you can move up a little bit, I want to see your, yes, here. Okay. This is the RDF XML code, because actually last time I mentioned as well, right, that try to write your graph model in RDF XML so that you can see how it works, and then try to use it, the W3C validator, to validate the correctness of your graph and your XML. This is very much following what we see from, oh, if you can move a little bit up, okay, that's fine now. Oh, okay, here, this is the declaration, that's fine. Second, this follow the what we learned for sure. If you copy this from the W3C, it will be fine too. DC, actually, you don't need. Actually, none of these, no, you use, okay. Remember, we say that this is namespace mechanism in which it allows us to use some kind of abbreviation, or it used for some form of, later on, we can make it like prefix for the abbreviation, right? Okay, but normally, all these abbreviations that refer to some URI or namespace of vocab, of some existing vocabulary. Normally, when people model some vocabulary, okay, design and model vocabulary to describe certain things, we can define them properly and then refer to them as some kind of what we call namespace. And in those namespace, you can refer to a URI of this whole namespace, such as for this one. What I can do. Okay, that's fine. Such as for this one, DC, right? It refers to this existing namespace, which is actually a standard one. And last time I said that DC is for Dublin core, and it is used for describing library objects, for example, mostly library objects. So they are related to books, they are related to resources. This book written by these people, author, and so on. Okay, so the purpose, remember last time I also talked about friend of a friend. So usually there are some existing or some standard. And it is always the good thing that we kind of research, we kind of reuse existing vocabulary or standard to describe something that other people may want to describe in similar way. So we don't create new vocabulary of our own every time, but we try to reuse standard one. Okay, so the thing I'm saying is that DC is an example of one. Okay, stand for Dublin Core. And if you go and search, okay, I will ask someone to search, or we will do some searching. It consists of something such as creator, vocab, keyword. As I said, it's for describing library resource. So when we kind of refer to DC and later on we say that DC flies from, DC flies to, they don't exist in the standard, of course. Syntactically, everything here that they share with us is perfect syntactically. Semantically, DC doesn't have these things. That's it, okay? But it seems like we try to say, oh, this belongs to DC. In which we will be able to correct them later on easily. Okay. So what you may need is actually, if this kind of thing predicate flies from and flies to, flies to are kind of new to us. Nobody defined before, and we want to be we want to define our own. We create our own namespace in the same way as URI, right? We need to find a way to make it unique. We define our namespace. You can say AIT, okay, to make it easy. Example.ait, and then slash anything for making it your own namespace. Okay, or make up something like example.com or whatever. We know that this is for kind of temporary purpose for demonstration. And what else here? DC operator. Okay, so these are basically the very first thing. Okay, I need to clear. And when we say about, it will refer to, okay, now look at RDF description, RDF about, and then this one. So please look at the graph a little bit. Can they move to the graph below? Yes. Okay. You could see that actually it has this, but it tries to make up with some, make it TG676 as a URI, right? But adding some prefix to make it URI. So this is because of the validator itself, but normally it would be good if actually your RDF about, because we are saying this is the whole thing about something. This could be good if you make the full URI of the object you define, okay? Because otherwise it will try to make up some URI for you in which it may not be the one you may want to refer to. Okay, so for Faye to do some correction, replace this with the URI you're supposed to make it designating to for this TG767. And then this is very good. But what is it? Operator flies from side to, oh no. Okay, can I go to your DC? Sorry. Okay, sorry. You use this as your own one. I didn't notice. You define it. This is Fei URI. Okay, very good. It misleads to me in the sense because you use the prefix, which is the standard. I mean, everyone who sees DC, if they are in this semantic web world, they will think of DC as the Dublin core one. But this is a kind of abbreviation. You can use DC, that is fine. Okay, now I understand. But you don't refer to the standard DC URI, okay, then that is okay. But try to make it meaningful, better meaningful abbreviation, okay, such as fly, such as anything, okay. Because those who overlook like me, I already assume that your DC refers to the standard DC. Okay. All right, what else? Then you see that every time, right, you use this DC as abbreviation prefix. So DC operator here, it will use this full URL as a prefix and then continue by operator. So if we go back to your graph, you could see that here. Yes, everyone could see. This is the operator. This is the fly from, flies to. The other problem I want to notice here, when it is a square rectangle, this is literal. We want them to become, resource. Not literal, because literal are like Shutiporn are just string. It doesn't have any meaning. In the semantic web graph, in the RDF graph, why literal is not good? Because with literal, you cannot further describe. When it is resource, it's an object. It can have further predicate. We want to make a graph connecting. When literal, this is terminal, the end. But when it is this, make it resource. We can always have the description provided further. So usually the intention was very good to refer to the Wikipedia Bangkok. This follow the principle of linked data, right? We refer to existing resource or reusing of existing description, because in DBpedia, all these have a lot of existing description in which many people already, DBpedia already described Tokyo with its own description, okay? So find a way to make this resource in the syntax. The syntax is wrong, so that it means it doesn't consider this as resource that link to existing resource. If you go to your syntax a little bit, I can correct this. The wrong thing is here. Can someone tell me or help me? Do you know what is wrong here? And that's why it makes the graph refer to this as literal, not as the same here too, not as resource. Anyone? Yes. So we change this syntax and then it will make it as a link. Yes. So Faye, you know how to correct this? If you know, you do it now. Yes. Just one is fine. Okay. Just only one statement that we correct, and the rest can be. You need to remove this first. And remove this. And remove the whole this. No, remove only this, right? I said remove this. This bracket. Just that character, okay? Space. You need to convert this not to the smart font. No, like this. And you remove all this. Okay, Control Z to undo this. Microsoft Word is smart. Yes, okay. Okay, now this one is correct, the operator, in terms of syntax. And then you can do the same for the other. And then if you can show the graph later on. Okay, this is the problem of using Microsoft Word or PowerPoint when they do kind of smart code and URL conversion and so on. So they're not good for writing the code anyway. All right, thank you, Faith. And we can go back to then if you can share later on, okay, I do the sharing myself. The resulting graph is supposed to look like this. And I think it will be the same for Risha that already shared. It should look like this in your graph. And as I said, the very good thing is that when you refer to existing resource, such as one on DBpedia, /tg always, it means that in DBpedia, there are actually existing description defined already by themselves, and that makes the link data really linking, right? Linking to existing resource description. Yes. Yes. Predicate, subject, predicate, object, everything that are supposed to be resources, they have to be URI. Okay. The reason, okay. So, subject. when there are graphs, right? Actually, you can have the same structure everywhere as long as this is the object. Or actually, in our notation, right, we call them resource. As long as there are resources, you can always describe resource in the same manner, such that resource has description and defined by something else, has another description, Whenever your description has the value which is a literal, then you cannot further explain, right? Because it's just a string. Then how can we further explain or describe a string text or anything? Okay, so that is the reason why I need to make sure that we correct all the objects in phase sharing to be sure that they are objects. And further description can be there. Predicate has to be everything here, which is the resources. They are clear to be URI because we want to uniquely identify something, right? With the URI, you can refer to, oh, this is Bangkok. Oh, this we mean Nepal. Oh, this we mean a city in Myanmar. Or this we mean that, and so on, right? It refers specifically to that, no matter somehow there could be synonym, as we said last time. Bangkok can mean a city, can mean a restaurant, can mean a university name. Who knows, right? So we can specifically refer to that exact object we want to refer all the time. The same for predicate. Oops. Okay. The same for predicate. No, we cannot. Oh, doesn't matter. Predicate should be a URI as well, because we want to give specific meaning. We want to uniquely refer to uniquely refer to the URI we want. Sorry, it's all that went back to, but anyway, predicate. Okay. For example, last time I already mentioned such as we have both names. This is for sure a predicate to describe a person. So the name here will have the value in which we will understand that it refers to a name of a person. But actually the word name, predicate name, can always mean the name of anything, right? You can give a name of everything, a name of a project, a name of your university, a name of anything. But whenever it is the name that is defined by both, it's always just a name of a person, for example. And the same for DC for Dublin core, not DC, title. You know what does it refer to? Title can mean many things, right? Can be our title, like Miss, Mrs., Mr., Master, Doctor. This is a title. But title in Dublin core, what does it mean? Title of a resource, basically a book. Title of a book, such as Introduction to Semantic Web, such as Database Model. This is the title of a book. So whenever we refer to this title with this URI of DC, it's that meaning. It's very precise meaning, no ambiguity. That what does it mean by your predicate title? So that is why URI predicate also needs to be URI so that it is unique. You can always define the meaning for your predicate specifically. Okay, all right. I need to go back to the sharing. Okay, then we are about to the shopping back, right? Okay, I return back here. It's the same as the flight description. We may want to describe this shopping item, such as this bag, in terms of its price, its availability, and many more. Okay, and yes, has anyone done this and can share? Anyone else besides those who already share and have your sharing ready? Mon, you have something? In PowerPoint that can be sharing? Yeah, let's try. Okay, can you come and get the microphone and then you explain a little bit?
Hello. For the shopping bag, I make it the description like price, availability, color, and size, and then I put the how to say the object like for the price it will cost like this price, and for this is the availability of the shopping bag item, and this is the color that will be available, and this is the size.
Oh, okay. Have color of 3, but usually if I am interested in a bag, I want to know which color it has, right? Not how many color it has, but it is available in black, in white, in blue, or something. Okay. Mon, have you followed the discussion, the explanation I gave? What if you need to improve this? What are the things we can improve this graph? Is this already good?
No.
Okay. So what can be improved? If I ask you to submit final version, what will be the revision?
For the color, I think I can make 3 objects from that 3 cycle, not just 3, but I can make like red, yellow, blue.
Okay.
Something.
But how can you correct?
And
you span from here, or you will remove this, delete this, and do something else?
I will make it this 2 more cycle, and
can you change it now? Just for example, get some idea. Can you edit? Change the value first. It's still misleading.
Oh yeah.
I don't think you predicate.
Oh,
The very important thing, your predicate has to be meaningful. If you want this to represent the color, This should not be. This should not be the name of has color. Oh, okay, has color of, then okay, fine. Okay. Anything else apart from this that you may want to improve?
The
This yes, thank you. Mon and everyone. This and this, they are different. Use them correctly. This means what?
object.
Object. Is it an object?
No.
An object is something you can describe. What will you describe 100 by?
No.
For example, my name as Chutipon. I don't know what to describe further, right? The word Chutipon is already literal. This literal, or I will say this, for this, better say resource or object, yes. Make sure you model them correctly. Which one is supposed to be resource or object? Can someone help me? Which one? I will color yellow for resource. Where here should be resource?
Availability.
Pardon? Resource.
Availability.
3 pieces can be resource or not? Such as a student age 29. Is 29 a resource or a literal?
Literal.
Pardon? Literal. Bag has 3 pieces. Should it be a resource or a literal? Literal. Your height is 170. Is it resource or literal? Literal. Your right? Your date of birth, the 1st of April, is it literal or resource? Yeah, that can be something else too, but usually, right, when you model that piece of data, normally some of them could be defined both ways, depending, but in most cases they are considered as literal, right? The date value, the text string that are just some textual value. Okay. All right. Oh, sorry. What's wrong? Yes. A Boolean itself actually can be just a literal or can be a resource because it refers to an instance true, an instance false. But normally, it can, in that way, it can be both ways. But usually, we are not converting every single literal as a resource because the resource number 1, you can say, oh, we want to model it as a resource number 1. Usually, true and false should be literal normally. The thing is, whenever it's a resource or object, you can always further explain. What? Further explain it. It's me, right? This is very sensitive. Further explain its description. If you never want to explain those descriptions and nobody wants, I mean, in certain common situation, regular situation, nobody wants to explain the word true and the word false in some other expand the meaning further, right? Then no, it's not necessary to model it as resource. As I said, the age 29. Why would you want to further explain it, right? 29 means what? No, it's just 29. It's just the value. The height, the age, value is just the value. Okay? All right. So first, make sure you differentiate the object or the literal correctly. Okay, that's one thing. My hands are making all the mess. Okay, what else that we can improve further? This is what? How shall we improve them? Should be URI, right? Not just the word. Of course, for example purpose, demonstration purpose, discussion purpose, we write something very short. But in the real practice, this always URI, okay? And more or less, these are the things. Yes, so 2 points. So Mon, you got anything unclear you want me to explain further? An object, sorry? Yes, yes. But none of your object here may be a URI, right? It depends. Maybe okay. Thank you. What else? Next. I need to share. Okay, there's still a few more. Okay, maybe we can have 5 minutes break. And after the break, for those who have not made yourself ready for some sharing, maybe let's say 10, 15, it's fine. After the break, I want more sharing of the remaining thing. Okay. Better if your sharing are in the form of sorry. Okay. So let's do it in 15 minutes if you can. Choose one of these and then I will request you to share for the car, for the liquor, no, only these 2, no more. But I believe that you will have different idea, right? I make it very open. If I ask you, Rakash, if I ask you, Son, even it's the same thing for car, I would get some very different description anyway, right? All right. Okay, so let's come back in 15 minutes. That means 10. Okay, 10 past 10. 10. Hello. I'm back. So for the car and liquor, anyone can share volunteering? Yes, Park Home. Okay. Which one you want to share first? The car. Can you have the microphone? Park Home is over there somewhere, so others can hear clearly.
Hello. Okay. Here is my result. So I start with the define the subject, predicate, and object. And SMS aspect represents, or I have predicate for example, the manufacturing, colors, fuel type, and year, stuff like that. And it's combined between a resource and literal, but I'm not sure it's correct or not. But when I validate, the result is generate this graph automatically, adding the gen ID from this one. Here is
Okay.
yes.
But can you explain your description?
Description.
Yes. How do you describe? This is your car. This is the URI. This is the description. This car has this and that. Explain the graph.
Yes. I use the URI to present what is inside the graph. For example, this car. So I have Ford company as manufacturer, and has color is predicate. And when I put the URI, it generates automatically like this. For example, color red and fuel type like diesel. And the last one is year. It is just a number. So I'm not sure how to put this one. So let's put a only number up. This is kind of different from other. And the syntax is yes,
Okay.
it is resource.
There's one misspelling. If you can correct this resource.
Oh,
I'm not sure whether that is the reason. Something.
Okay, oh, it should be
Yes.
like
Okay.
this.
Because it looks strange to me.
Okay. Yes, this is to be the update correct version.
Okay. And the dbpedia data rate, dbpedia data decel, does it exist?
Yes.
Okay, these two resources really
Yes.
exist, right?
Yes.
Okay, very
Searching
good.
on the Wikipedia.
But okay, all right, very good. Anything else here? Any question from friends? Okay. Your URI namespace, can I have a look at the namespace used here? X car. Okay, you define example.com cars to be your own prefix X car. Okay, fine. Good. Thank you.
Thank you.
Others for the second sharing, anyone wants to share? We can talk about liquor. Yes, okay.
Sorry. So on the left side, we have the subject, which is a URI that's liquor, and the first one is a predicate that's what's the name of the liquor. So I've just given it XYZ liquor, and the second is what category it falls into, and in the right side I've given a oval shape for category liquor. And then the alcohol content I thought was literal, so I've given it a box 30 with data type float. Then what's the flavor of the liquor? I'll give it vanilla. What country is it from? France. What's the price? I've just given it a random $25 US. And for available, like, is it in stock or not? I've given it a Boolean value of true.
Okay, very good. And what if you want to draw, write this in RDF XML? You know how to convert into the corresponding syntax?
I have tried. It's validated, but it doesn't give me a graph. Maybe because it's not DBpedia links.
It will give. Why not? Can you show? Maybe you didn't choose that you want to show the graph or what? I'm not sure. Here. Yes. So this is supposed to be the same as what you draw yourself?
Yeah, with some change values.
Okay,
Oh yeah.
exactly.
Yeah.
More or less, it looks the same. Okay, thank you. Others, any different things you want to share or any idea that you have if something different and you want to get my feedback or the friends want to share it to the friends as well? Pochanan and Tan, you want to share something? No? You have your result the same? Okay. How about Paramik? Now, where are you now? Yes.
Yes, Professor. So, share my screen. So for the liquor,
Okay.
I kind of got,
the total, right?
yeah.
Okay, please do the explanation. Yeah, I'm following here.
Yeah, for the liquor, the properties are like the name of the liquor, the type, like whether it's a whiskey, vodka, or the brand, the alcohol content, that is the percentage of alcohol, the size of the bottle, the country from where it has originated, the ingredients, the age, the price, and the description. So I haven't drawn the graph. So it's like we are taking the RDF, like type is EX the liquor, and the name is like Glenfiddich. It's a Scotch whiskey. A brand is Glenfiddich. The alcohol content is like 40%. The bottle size is 750 ml, and so on and so forth. So not sure whether this is how it should be done, but
Okay, very good, Haramik. What I would suggest actually refer to the link data principle. I will say that there are few things that you may consider them for sure. This is already a resource, but the rest seems to be just literal. And of course, this is fine. This is by nature, they are literal. These, I don't think they should be literal. You can define many types, right? As many types of the resources, such as whiskey, wine, many more. I am not expert in liquor, but beer and so on. So they should not be literal. The brand, actually it should refer to the manufacturer, the provider, or the brand that is itself a resource. It is fine by nature. Country of origin, right? For sure, Scotland is a resource that someone else may already describe, such as in Wikipedia and so on. Ingredients. The main ingredient. I think this can be a resource as well, so that people can always query. Later on, we will look at the query mechanism, computing mechanism. So we may want the specific type of object or specific instance. Then we can do the query. What can we make by malted barley and so on? This is clear to be literal. Fine. This is for sure description literal. So this will be my suggestion, Paramik.
Okay. Yeah.
And I believe that it's also straightforward, right? This is in Turtle. You can also, for sure, Turtle is kind of very compact, in which I like very much. You may want to try to make sure you understand also the syntax of the XML syntax one. So if you want to try, validate it, create XML syntax and validate it further, that'd be good. So this will be my suggestion. Thank you. Okay. All right. Okay, others, anything else? I think we are done now up to that point of the exercise, okay, and sharing and my feedback, so that please be sure you incorporate, you understand the feedback, the comments I gave to you directly or I gave to other friends, but I think they are kind of common things that usually many students who first learn about this may have some doubts or unclear issues, okay? So before I continue a little bit, but I think I mentioned last time already that with the graph form, usually this is easiest way to understand it visually, but then serialization is the way that we normally need when we want to store the RDF data in computer system. We want to exchange, we want to send the RDF description and so on. We never send the graph, right? It's very difficult. So we need serialization to make them in the text form. And there are quite a number of existing syntax format, okay, that you can use. We already talked about this. Why it doesn't work for me? One moment. Okay, we already talked about this. Okay, this I will skip. The rest I want you to kind of make it make the understanding by yourself. Okay, what Paramik share is the total. Actually, I would say that it depends. Somebody have preference in terms of RDF XML is kind of the very first syntax that was born and defined as recommendation by the P3C, but it's very lengthy. Turtle is a kind of compact, shorthand and easy to understand in a doesn't take a lot of space, okay, to read and to understand. N-triples and N3 also available, and there are many tools as well. And as I already mentioned last time, JSON is here, right, as kind of those who are familiar with coding, programming, they're familiar with JSON. So why not using RDF JSON, something like that, okay? So please be sure you kind of understand, but normally we can choose some standard that we are familiar with for just one. All of them are kind of convertible anyway. There could be tools that convert from RDF XML to Turtle, Turtle to N-triple, N-triple to JSON or whatever. So if you understand one, then there are available tools that you can use as well. And I will go quickly for maybe the Turtle, because I use quite a lot in terms of Turtle. When you may want to write shortly, and in many tools we learn later on. So be sure that you understand Turtle. Later on, we may need to use Turtle in some other tools, Query, Sparkle, Engine as well. Okay. The first thing, you can define with this prefix keyword. Okay, you can define any prefix, any abbreviation you want, and then the namespace. So this is the very first thing you declare in your Turtle syntax. If you have many prefixes, you define them at the beginning. It can be 10 of them, 20 of them, 2 of them, or none of them, that's fine. And allows you, right, that once you define RDF as a prefix, both as a prefix, you can use them here, okay? You can use them either for the subject, predicate, object part. But normally the subject is the URI that you define, so it should be full. URI will be in the form of this. Okay, this syntax is for URI. That means you need this angle bracket. After that, it is just so actually it's very easy. Okay. Usually every RDF statement, right? RDF triple, RDF graph, it is in the form of subject, predicate, object. The same principle apply for Turtle. So you start with the prefix statement. After you start with prefix statement, you just write subject, predicate, object. And you might see here that normally, if you write only subject, predicate, object, then they are fine. But sometimes you don't want to repeat the same thing. Sorry. Oops. Paramik, are you still there? May I
Yes,
have a
Professor.
look at your syntax a little bit? I want to see whether you use some kind of abbreviation for the statement or not.
Yes.
Yes, you can share. I already stopped.
Yeah, I shared my screen.
Okay, okay. All right. Have you tried making the full form? But have you validated yours? Sorry. Have you found a way to validate your total?
No, not really.
Okay, not really. Okay. Okay, never mind. Then that's fine. I will explain a little bit more. Okay, I didn't provide more of the example here. Okay. Normally, the very easiest way is to write every sentence separately. And each sentence is finished by a full stop. Okay. So we can have RDF statement 1, statement 2, statement 3, and so on. And then we write in a way that, okay, I should not. You have this statement 1, subject, predicate, object, and full stop. Subject, predicate, object, and full stop. Subject, predicate, object, and full stop. But sometimes we want to do things in a similar way as writing English. You want to combine things, right? You are not writing that John eats apple, John eats rice, John eats noodle, John eats something like that. You want to say John eats apple and rice and noodle and so and so and so on and so on, right? So in that case, there are several ways that you can combine them, the sentence, the statement. That is, let me see. If object 1, object 2, object 3, okay. Instead of saying subject, predicate, object 1, subject, predicate, object 2, subject, predicate, object 3, you can say subject, predicate, object 1, comma, object 2, comma, object 3, full stop. This is one way. You can do the same like this, but every time you write anything, try to make indentation for readability, right? Because human wants to read this easily too. Or another way, okay, I make it box so that I can see. You can say subject, predicate, object 1, semicolon, predicate, object 2, semicolon, predicate, object 3. When it is the end, you full stop. So semicolon is used when you only keep the subject part, but you change the predicate every time. So this case, you can have new predicate too. Predicate 1, predicate, different predicate, I mean. All right. So actually there are kind of a number of ways we can write the same thing, but it's just as we already mentioned, syntactic short form to make what we write shorter, because maybe we want to make it easy to read and don't consume a lot of time to read the statement, the description. Anyway, this is just the syntax matter. But more or less, what is important for RDF statement still it's this subject predicate object notation. That's the main principle. All right. I think that's all. The rest is just similar. You just go and perhaps try to read and understand them.